Wow, we just finished reading The Sunlit Man by Brandon Sanderson. This is an adult fantasy book with some violence and a bit of torture, but young adults who can handle that might be able to enjoy it too. It also borders a little bit on science fiction. It is so full of astronomy and physics and magic and faith, all topics I love to think about. The book is dedicated to Cosmere fans. In fact, the main character, who's called Nomad in this book, is from another Cosmere book. I'll let you figure out from where. There's so much I could talk about, like the lovable characters, and the gripping plot, the interesting culture and history, but lots of other people will talk about those things. So instead, I want to talk about the astronomy in the book. In the foreword, Brandon Sanderson said that he consulted with an astronomer for this story, so that sounded pretty promising. And it turns out the astronomy was pretty accurate. For the parts that weren't, I guess you can explain it all with magic. So, let's talk about the planet Canticle, where this story happens. There were a lot of weird, funny things about this planet Canticle. It's a teensy-weensy little planet, first of all. It only takes like 4 hours to fly around the planet in hovercraft that are moving so slowly that you could fall off one of them without getting very seriously hurt. I'm not sure how fast that would be, but let's say it's the speed limit here in my city, which is 50 kilometers per hour. That means the planet would only be about 200 kilometers around if their hours are the same as our hours. That's like a mid-sized asteroid only. But it seems to be pretty round with normal gravity and air pressure, so it must be pretty dense. I couldn't figure out how dense, so I got my buddy to help me with the math, and it turns out that Canticle must be about 100 times denser than lead, and like 50 times denser than the densest naturally occurring elements in our universe. A rock from Canticle the size of a tennis ball would weigh like 200 kilograms, unless of course there's magic involved, which the story seems to suggest. Another fun thing about Canticle is that it has rings like Saturn does. It must be pretty spectacular to see rings in the sky, but Nomad says the rings aren't going around the equator. There's probably some magic involved, but if we discount the magic and assume ordinary physics, then the rings should have the same center as the planet, even if they don't circle the equator. So they could be tilted at an angle like this, or they could be circling the poles like this, and those would be called polar rings. But one characteristic of the planet Canticle that drives the whole story is that the sun is really, really hot. It's so hot that humans have to constantly keep flying around the planet to stay away from the sun's heat and stay alive. The sun is so hot, it melts the planet's surface and remakes it every single day. So, the next time you come back around to that part of the globe, you won't be able to tell where you are because the landmarks are all different. And this is where astronomy comes in useful. Say you left something behind on the ground on the last rotation, like maybe a sun heart or something like that. How would you know where to find it again? And that's a major part of the story. Well, the locals on Canticle figured it out. Here's what they have to say from chapter 15. Well, the stars can tell us with reasonable accuracy where we are on the planet. The corridor we're in, they mean the latitude, is easy to determine. Harder to tell the longitude, however. You need precise clocks. So what were these people talking about? How can we tell the latitude without GPS? You may have heard that the constellations are different between the northern and southern hemispheres on Earth. So in Canada, we see the Big Dipper, and in Chile, we see the Southern Cross. This is because the Earth is round, and the planet blocks our view of half the sky. The changing constellations is how we can tell our latitude on the Earth without GPS. In the north, it's the changing position of the North Star. As we know, the Earth is a spinning sphere. Here are the lines of latitude and longitude. The equator has a latitude of 0 degrees, while the North Pole has a latitude of 90 degrees. If you draw an arrow from the North Pole along the axis of rotation, it would point to the North Celestial Pole. It so happens that Polaris, or the North Star, is almost right on top of the North Celestial Pole. On Earth, it doesn't feel like we're the ones spinning, and it actually looks like all the stars are spinning around us on a great big sphere. But Polaris, being in the same line as the axis of rotation, looks like it stays in the same spot as all the other stars rotate around it. Let's pause the rotation for a moment and see the view of the sky from the Earth near the equator. Say from this great big lake with many names. Notice that Polaris is really close to the horizon, where the sky meets the ground. Now let's move northward. As we travel northward around the Earth, Polaris rises into view and gets higher into the sky. When we reach the North Pole, Polaris is right over our heads. So, the angle of Polaris's position in the sky tells us our latitude. If Polaris is right over your head, its angle to the horizon is 90 degrees, and that means you're at a latitude of 90 degrees north, or at the North Pole. If Polaris is 50 degrees above your horizon, then you are at 50 degrees north latitude. And if Polaris is right on your horizon, then the angle is 0 degrees and you must be at the equator. The same principle applies in the southern hemisphere, even though there isn't any South Star there. The reason why latitude is so easy to tell, it's because the view of the sky doesn't change in the north-south direction as the planet spins. But longitude is a lot harder to tell because the view from a single spot keeps changing in the east-west direction as the planet spins. Nomad notes that you need an accurate clock to tell what longitude you're at, and you also need a reference point. On Earth, the longitude of Greenwich is the reference point. There's a historical reason for why that is. Back when there were no planes or GPS, people had to sail around the world in ships. There was an important port near the Greenwich Observatory. Every day, a great big ball on top of the Greenwich Observatory would be dropped at 1 p.m. sharp. That ball was visible from the nearby port. So sailors, seeing the ball drop, would set their clocks to 1 p.m. Greenwich time and then set sail across the ocean. Then, in the middle of the ocean, if the sailors saw that the sun was at high noon, but the clock said it was already 3 p.m. in Greenwich, then they knew that they were probably about 1/8 of the way around the Earth in longitude. And that's why Nomad said you needed an accurate clock. And now you know how to find your position without GPS. I really loved how Nomad kept asking all the right questions about such a weird planet, and it really is a weird planet. He really did have the heart of a true scientist, even if he had kind of left that life behind. It was still in his heart to keep asking questions and to keep being curious about the things that he saw around him. Well, I hope you had fun being a scientist too and thinking about all the physics and astronomy and the magic of the planet. I certainly did. I can't wait to read more. Bye-bye!